Hi, I'm Karan from Karan Staff Technology. You are K20CS007. This video we are going to see about the banker's algorithm. Just we starting from the code base condition. So base condition as include of the stdio.h and stdio.standard standard library. After that, the logic of this banker's algorithm is the resource allocation of the deadlock avoidance algorithm that tests for the safety by simulating the allocation for the predetermination maximum possible amounts of all resources. Then make an estate check that is to possible activities before deciding whether the allocation should be allowed to continue. And in this first we want to enter the total number of processes. That we want to enter the total number of resources, and we are assigning that 2D array and the 2D array of m of a maximum and w of work. So we are assigning that. Other we are using to for iteration it will be giving the process of p0, p1, p2, p3, p4, p5 like that, and we want to get an allocation to be iterated. So we want that allocation for the resource of mod p, and the j plus 1 will be the index will be skipped. So it started from the 1. The maximum of the resource will be also the 1. First, will the available, it is a 1D array of size of m indicating the number of available resource of each type. Available of j equal to k means that or k instance of resource type rj, and the max will be the definition of if it is a 2D array of size n multiplied by m that defines the maximum demands of each process in a system. The maximum of ij k means the process of p of I may request at the most of k instance for resource type and rj, and the allocation in the 2D array of the size n multiplied by m that defines the number of resource of each type currently allocated of each process, and the allocation of I comma j will be the k means resource of pi is currently allocated of k instance of resources type need. In this need it is 2D array of size of n multiplied by m that indicates the remaining resource needed of each process need. I comma j equal to k means process pi is currently needed of k instance of the resource type for j, and the need of I comma j need will be calculated by the maximum of I comma j minus allocation of ij. The allocation specifies resource currently allocated to the process pi, and the needy specifies the additional resource that process pi may still request to complete the task, and the banker's algorithm consists of safety algorithm and the resource request algorithm. Let the work in this the algorithm is to let the work finishes vector of length of m and n, m and n. After that, it's respectively initialized to the work equal to variable. We are iterating. First, we have to bring that allocation of matrix and the maximum requirement matrix to be tabulated. After that, we are using that 2D array of allocation and the need, the b of 1 to 10. So we will iterate it between each other. Then we have to give a resource request algorithm for this wide request of array of all availables and needs to be mentioned. So we want to enter additional request for this algorithm. For the error, if we give a wrong answer, it will be given as an error encountered. The resource will be available. Check whether, and we want to give them for request resource request algorithm that the request I be the request of array for process pi requesting j equal to k means pi wants to k instance of resource type rj. When a request for the resource is made of pi, the following action taken if a request is greater than or equal to need. the I go to step. Otherwise, raise the error condition since the process has been executed its minimum time. If the request is greater than or equal to available, otherwise PI must wait the resource are not available. As the system pretended have allocated the requested resource to process of PI by modifying the state, and the available will be calculated by available minus request of I, and the allocation will be allocation plus request of I, and the need will be calculated by the need of I minus request of I. So the Banker's algorithm will be tabulated, and it will verify the program by running the output. Here there is an deadlock avoidance of Banker's algorithm. First we get the process, then the number of process will be 5, and until the total number of process will be 3. And the process for allocation for the resource will be 0, 7, 1, 5, 0, 3. And the process 2 allocation for the resource 2, 3, 0, 2, 0, 3. And the process 3 will be 3, 9, 0, 0, 2. The process 4 will be 2, 4, 1, 2, 1, 2. And the process 5 will be 0. The maximum of resource will be 4, 0, 3, 2, 3. The available resource to be calculated by the adding of this allocation of resource, adding of allocation matrix. After that, we want to subtracted by the instance of just an example of 10, 7, 10, 5, and 7. So it will be calculated as 10. It will be 3, 3, and 2. Then the matrix will be the allocation of matrix 0, 1, 0, 2, 0, 3, 0, 2, and 2, 1, 0, and 0, 0, 2. And the maximization of request will be 7, 5, B, and 3, 2, 2. And the need matrix will be it will be subtracted with an allocation of matrix and the maximum requested matrix. So it will be 7 minus 0 will be 7, and 5 minus 1 will be 4, and 3 minus 0 will be 3. And the 3 minus 2 will be the 1. After that, 2 like this, it will be iterating and minus by the meter of matrix. After that, it will be checking whether the remaining available of this algorithm to calculate the safety sequence has been detected. So the safety sequence has been detected as an P1, P3, P4, P0, and P2. If you want to continue means we give yes or no. So I give 0, no. So program executed successfully. Thank you.